This lecture focuses on the effects of air pollution on both human health and the environment. Here are the learning objectives for this lecture. By the end of the lecture, you should be able to answer the following questions. In what ways can air pollution affect human health? In what ways can air pollution affect the environment? The consequences of breathing dirty air include increased probability of heart attacks, respiratory diseases, and lung cancer. This can mean as much as a 5 to 10-year decrease in life expectancy if you live in the worst parts of Los Angeles or Baltimore, for example. How does air pollution cause these health effects? Because they are strong oxidizing agents, sulfates, sulfur dioxide, nitrogen oxides, and ozone irritate and damage delicate tissues in the eyes and lungs. Fine suspended materials penetrate deep into the lungs, causing irritation, scarring, and even tumor growth. Heart stress results from impaired lung functions. Carbon monoxide binds to hemoglobin, reducing oxygen flow to the brain. Headaches, dizziness, and heart stress result. Lead also binds to hemoglobin, damaging critical neurons in the brain and resulting in mental and physical impairment and developmental retardation. The environmental effects of air pollution can involve similarly complex and often gradually accumulating effects. We have already discussed particulate matter in earlier lectures. Particulate matter is the sum of all solid and liquid particles suspended in air, many of which are hazardous. This complex mixture includes both organic and inorganic particles such as dust, pollen, soot, smoke, and liquid droplets. It is the smallest particles in the range of 2.5 microns in diameter that can penetrate most deeply into lung tissue and be the source of inflammation and reduce oxygen transport from lung tissue to the bloodstream. Deposition of acidic droplets or particles from rain, fog, snow, or aerosols in the atmosphere became recognized as a widespread pollution problem only since the 1980s, but the effects of air pollution on plants, especially sulfuric acid deposition, have been known in industrial areas since at least the 1850s. Acid deposition is now understood to affect forests and croplands far from industrial centers. Rain is normally acidic, with a pH of 5.6, owing to reactions of carbon dioxide and rainwater, which produces a mild carbonic acid. Industrial emissions of sulfur dioxide, sulfate, and nitrogen oxides can acidify rain, fog, snow, and mist to a pH of 4 or lower. Ongoing exposure to acid fog, snow, mist, and dew cause permanent damage to plants, lake ecosystems, and buildings. High elevation forests are most severely affected by acid precipitation. Mountaintops often have thin, often acidic soils under normal conditions, with little ability to neutralize acid rain, snow, and mist. On Mount Mitchell in North Carolina, nearly all the trees above 2,000 meters or 6,000 feet have lost needles and about half are dead. Acid precipitation over the United States in 2000 is shown in this figure. Many areas have improved markedly since then because of the new rules on sulfur dioxide emissions and other pollutants. Note that most of the problem areas for acid deposition are in the eastern portion of the United States. This coincides with emissions from oil and gas processing and industrial emissions. The effects are also based on prevailing wind patterns, which move from west to east. How does this map compare with the long-range transport map we looked at in the second lecture in this chapter? Acid rain can have profound effects on both flora and fauna. In this figure, we see a large fish kill following spring snowmelt. Acid compounds build up in winter snows. The spring melt brings large slugs of acidic water into aquatic systems and results in fish kills and other health effects, such as reduced egg composition, decreased growth, deformities, and susceptibility to disease. The mass death of fish results in the loss of food, which affects birds and other predator populations which rely on the fish. Whole ecosystems are affected. In cities throughout the world, air pollution is destroying some of the oldest and most glorious buildings and works of art. Smoke and soot coat buildings, paintings, and textiles. Acids dissolve limestone and marble, destroying features and structures of historic buildings. The Parthenon in Athens, the Taj Mahal in Agra, the Colosseum in Rome, medieval cathedrals in Europe, and the Washington Monument in Washington, D.C. are slowly dissolving and flaking away because of acidic fumes in the air. Acid deposition also speeds corrosion of steel in reinforced concrete, weakening buildings, roads, and bridges. Limestone, marble, and some kinds of sandstone flake and crumble. Atmospheric acids, especially sulfuric and nitric acids, have almost eaten away the face of this medieval statue. Annual losses from air pollution damage to buildings and materials can amount to billions of dollars. The Council on Environmental Quality estimates that U.S. economic losses from architectural and property damage from air pollution amount to about $10 billion every year. In urban areas, pollution is most extreme when temperature inversions develop, concentrating dangerous levels of pollutants within cities. A temperature inversion is a situation in which stable cold air rests near the ground with warm layers above. This situation reverses the normal conditions. Usually, air is warmed by heat re-emitted from the ground surface, and it cools with elevation above the Earth's surface. Warming air rises, mixing the atmosphere layers and helping pollution to disperse from its sources. When cool, dense air lies below a warmer, lighter layer, air remains stable and still, and pollutants accumulate near the ground where they irritate our lungs and eyes. Stable inversion conditions are usually created by rapid nighttime cooling, especially in a valley where air movement is restricted. Los Angeles has ideal conditions for inversions. Mountains surround the city on three sides, reducing wind movement. Heavy traffic and industry create a supply of pollutants. Skies are generally clear at night, allowing rapid radiant heat loss, and the ground cools quickly. Surface air layers are cooled by contact with the cool ground surface, while upper layers remain relatively warm, and an inversion results. As long as the atmosphere is still and stable, pollutants accumulate near the ground, where they are produced and where we breathe them. In this figure, we see a visual representation of a temperature inversion. Atmospheric temperature inversions occur where ground-level air cools more quickly than upper air. With cold air resting below the warmer air, there's little mixing, and pollutants are trapped near the ground. Heat islands and dust domes occur in cities even without inversion conditions. With their low albedo, concrete and brick surfaces in cities absorb large amounts of solar energy. A lack of vegetation or water results in very slight evaporation, which would be latent heat production. Instead, available solar energy is turned into heat. As a result, temperatures in cities are frequently 3 degrees to 5 degrees centigrade warmer than in the surrounding countryside, a condition known as an urban heat island. Tall buildings create convective updrafts that sweep pollutants into the air, and stable air masses created by this heat island over the city concentrate pollutants in a dust dome. Reduced visibility is a widespread impact of air pollutants, as on this Los Angeles afternoon. Molecules in the air scatter blue and violet more than the longer wavelengths of yellow, orange, and red. This same Rayleigh scattering turns the sky from blue to combinations of red, orange, and yellow as the distance between the sun and your eye increases, because the light has to travel through more of the atmosphere. Factory and coal power exhaust, car exhausts, and leaking gas, as well as the byproducts of burning plastics and aerosol spray cans, send far more particles into the atmosphere than any natural events do. This smog is a mixture of chlorofluorocarbons and hydrocarbons, sulfuric acid, and other human-made chemicals. Smog from a smokestack or car is composed of particles of very many different sizes, and the scattering is nearly indiscriminate. Rayleigh scattering is no longer in effect, since instead of the atmosphere scattering only certain wavelengths as sunlight passes through it, it scatters everything. The aerosols in smog are varied and relatively large, to the point that they can scatter every wavelength of light. The result is a sunset with no colors at all. The sky is simply a hazy grayish white, with all of the yellow, orange, and red having been scattered out before they could reach the eye. Chances are, if you're seeing an especially colorful sunset in Los Angeles, it's because the smog is low that day, not because it's heavy. We've only recently realized that pollution affects rural areas as well as cities. Even supposedly pristine places such as our national parks are suffering from air pollution. Grand Canyon National Park, where maximum visibility used to be 300 kilometers or 185 miles, is now so smoggy on some winter days that visitors can't see the opposite rim only 20 kilometers or 12.5 miles across the canyon. Mining operations, smelters, and power plants, some of which were moved to the desert to improve air quality in cities such as Los Angeles, are the main culprits. Huge regions are affected by pollution. A gigantic haze blob as much as 3,000 kilometers or 2,000 miles across covers much of the eastern United States in the summer, cutting visibility as much as 80%. People become accustomed to these conditions and don't realize that the air was once clear. Studies indicate, however, that if all human-made sources of air pollution were shut down, the air would clear up in a few days and there would be about 150 kilometers or 90 miles of visibility nearly everywhere, rather than the 15 kilometers to which we've become accustomed. Recent studies have shown that rural sources also impact urban areas. In some parts of Los Angeles, for example, ammonia drifting from nearby dairy feedlots cause as much smog as cars do. Dust, pulverized manure, and methane are additional airborne pollutants that drift from dairy feedlots into the city. Wind-blown dust from cultivated fields is also a dominant cause of impaired visibility in some regions, especially during spring and summer. Air pollution has serious consequences for humans and the environment. In humans, air pollution causes damage to sensitive tissues such as eyes and the respiratory tract. Particulate matter can accumulate in lungs and cause long-term irritation and tumor growth and interfere with oxygen uptake. Carbon monoxide and lead can bind to hemoglobin, further reducing oxygen uptake. Human lifespans in large cities are often reduced by as much as 10 years. The effects of air pollution on the environment are widespread and serious. Acid deposition damages forests, impacts aquatic organisms such as fish, and damages buildings and structures made of stone. The environmental and health effects of air pollution are exacerbated by natural atmospheric conditions such as temperature inversions, and air quality can be impacted both in cities but also in the countryside from agricultural or industrial operations.